Okay, so we're going to do another series of tests here, and this time you can see that this has the ring on the end of the potential coil, and then it has this loading ring here. On this side here we have the ring on the end of the coil, but we do not have the loading ring, so that is completely removed. And that's this unit right here, which was up here and it was hooked in series with that ring. So we've removed that. System is unbalanced, and also there's no connection to the neutral. And so what we're going to do is we're going to go through the resonant frequency where the meter is peaked at 100%. I'm not going to turn it, I'll just leave it there because it's so sensitive, but this will be close enough to see where we're at. And so we're going to do the resonant frequency where it's peaked, and then we're going to drop the frequency down on the lower end until it's at 70.7%, about 70%. And we're going to go back up to resonant and pass it until the meter is back to the 70% range. And we're going to look at the bandwidth and the multiplication factor with this particular arrangement. Okay, so for right now we're peaked, and the amplitude of this, rather than being 10 volts at the max, it's so sensitive we had to reduce the voltage on this. But in any case, it's at 7.38 volts right now output, and we have a frequency of 5412 kilocycle. So 5412 kilocycles. Now I'm going to go down in increments of tens, 100 cycles. Okay, so I'm going to go down until the meter is at 70%. And 7 on the DC is about 7.07 on the AC. Okay. 5409. Pretty tight. Okay, then I'm going to go back up to the peak, and I'm going to go past, and the needle's peaking. I'm going past, and then it's going to be dropping at some point. Okay, it's starting to drop slowly. Okay, here we go. And we're just about right there. And of course my hand being on the meter, on the dial right here, is influencing it a little bit, because when I pull it away it comes up just a hair. But in any case, we'll take that reading. That's 5420 kilocycle. 5420. So we have a bandwidth of 11 because the center is 5412, the lower is 5409 kilocycle, upper is 5420, so the difference is 11. And then if we take 5412 and we divide that by 11 kilocycle, and we have a multiplication factor of 492, which has dropped down about 80 kilocycle, or 80 times, or 80, because it was 576.94 when we used the more accurate meter last night with both loading rings on, and by taking that one ring off, the bandwidth went up just a little bit, and the multiplication factor went down. Because you're distributing the power over a wider range,
well,
right?
It's right now this thing is transmitting right now because of the imbalance. That's the complication.
So it's not a closed.
It's not a closed
asymmetrical
loop anymore. So now the the ground plane is, well, it's not too bad, not as bad as it was, but you can see now that the ground plane itself is hot because there's no neutral point anymore. Now the whole thing is pulled sideways until the arc gets going. So
right now it actually is trying to seek ground.
Yeah, and if I grounded the neutral, then the thing, the two coils can't see each other anymore, and we didn't get a good peak on that.
Okay.
But what we want to do now is try to get it balanced by using the fluorescent lamp to replace the ring and find the optimum spot to light the lamp. With this compensating for the lamp's capacitance. You see what I'm getting at?
Yeah, so we're going, so it should be balanced.
When this
Ideally.
is connected, or
Yeah,
when
and
it's
tuned up,
connected.
right.
This is going to be our spark.
Yeah. So we're going to do that
Touch it to the ring.
on this end?
Yeah.
Do you want to do that right now? Or,
Yeah, that's the next.
Or do you want to do this measurement first?
Well, we could and show how screwed up it is. Let's ground the neutral.
Okay, so we're going to do the same test, except we're going to ground the neutral on the center tap transformer there, sitting under the current coils.
Okay, now you have to do the whole search and everything all over again.
Okay.
So you're going to have to start off sensitive. So use that to kind of get yourself started. Hold it up high.
Let's see, go to tens.
Yeah, go back to the...
Oh, we're already there.
Okay. Should have a good peak. It seems to have a good peak.
I don't know if you can see that meter here. It's peaking pretty good. Okay, so we're going to
Not as strong as it was before. There you go.
1 kilocycle steps. Okay, now I'm going to go down to 100 kilocycle steps.
100 cycle steps.
100 cycle steps.
It's about as strong as it was before.
Okay, so that's about it. So you're going to bring the voltage on here to ping that, or to
Yeah,
peak
yeah,
it?
to do the...
Okay, so I'm going to go up in amplitude in hundredths of volts. Okay, that'll take a little while. Okay, so here we go. About right there. So if I move my hand, the meter drops. So I'm going to compensate for that a
It's
little bit.
sensitive now
So
because it's connected to the plate. See how the plate influences
yeah.
the situation? So the plate is really... Let's see how hot the plate is now.
Oh yeah.
It's hotter.
Here, turn it sideways a little bit. Okay. Okay, so on the meter, by hitting the ground plane, it's peaking the needle on there.
So it seems like the best thing to do is, at this point, well, go through the frequencies and all that, and then I think when we operate it with the lamp, we'll leave the neutral floating. Because it's not really a neutral anymore.
Okay, so we're about at 100%. Okay, so now we're going to redo the numbers. Same way, grounded neutral. That neutral, the center tap is connected to the ground plane here. Okay, so we're at the center right now, and this needle is pretty much at about 100%. 5330 kilocycle. 5330.
So did it go up or down?
Went down about 100. Okay, so I'm going to reduce the frequency until we're down to 70%. Or 1,000 steps. Right there, and go down to hundreds. Let's see. I got to compensate for me moving my hand, so I got to dial it to where it's maybe 75, and when I move my hand, then it'll drop to the 70% place. Just a little bit more. A little bit more. A little bit too much. Okay, so we're at the where we want to be. That's 5323. And that's the lower, 5323. Now we're going to go to the upper. As we go past the peak, come down. That's really okay. We'll go down to the hundredths. More. More. Just a tad bit more. Okay, we're there. No, that's a little bit too high still. Okay, now right there. There we go. Okay, 5340. So we're looking at a bandwidth of 17 kilocycle, which is even wider, so the multiplication factor will go down. So we have a center frequency of 5330 divided by 17 kilocycle bandwidth is a multiplication factor of 313.53. So it went down quite a bit. That went down about 180 or so.
Makes sense because it's transmitting now.
So you're losing it.
Yeah.
Okay, so that's that test, and then what we'll do next is we'll do this same kind of test with the light on here, and we'll tune it with the light as part of the equation, and this is going to compensate for it. That's why we have a missing ring, so that ideally that ring kind of matches the bulb.
Yeah, and
which
then,
is going to
then it
replace
should
that loading
balance. Yeah.
Yeah, then it should balance, and that'll be the configuration to actually do the flame speaker.
Well,
Sort of.
we'll see.
Yeah.
Right now we're kind of, seeing how this thing balances out. And
So do we want to do the light both with neutral and without?
well, I don't think it'll light with the neutral. Let's start with out the neutral. See if we seem to
Without.
have a higher potential then, but it's hard to
Okay.
say because this is hot now, so we're getting all these, neutral planes everywhere. See how much hotter it is?
Okay, so we got to reposition this so I can bring the voltage down on this.
Well, right now we already went through all the tests, so we just need a regular field strength meter now because we're not doing precise
Okay.
measurements. We're trying to get the light tuned up.
Okay, you gonna hold the light?
Yeah, and we get just use. Well, it works okay there, but this is handy.
Okay, I'm gonna stop this video and restart it. Okay, so what we're doing right now is we're kind of redoing the lopsided arrangement with the missing loading coil on the end, and the tube is replacing the loading coil so that it would be balanced with the load of the lighting up and being up in that area. Right now the end of the tube is about maybe 2 inches now, about 3 inches away from the coil, the end ring, and as it gets dimmer, Eric is adjusting the frequency to keep it lit, because each time he brings it a little bit further away it's going to decrease the capacitance, so the frequency is going to go up a little bit, and so he'll just keep adjusting little by little for that.
Quite getting spark. We haven't turned the voltage all the way up yet, have we?
No, it's at 9.99.
Okay, that's all the way up.
Yeah, might as well just make it an even 10. And then put it back on frequency. Okay, you're in the 1,000 range.
Still doing pretty good.
So it's about maybe 10 inches away.
Seems to like it better the other way. With the grounded neutral, it's even worse. So the capacitance compensation for the spark might be problematic. Might have to leave it symmetrical. It's doing pretty good though.
Yeah, you're
Well, we
about.
don't know until we start launching. But basically, we're supposed to compensate for this.
Yeah.
That seems to really.
It's about 3360 kilocycle ballpark range.
I kind of lost my place. There it goes.
Where do you want it to be?
Well, I'm trying to get back where it's hot again.
You're 5400 right now. There you go. Okay, so that's about 5380 to kick it off.
Connecting the tube seems to really overload it. Let's light the tube up about here.
So it's about about 4 inches away from the ring now.
That's a good spot. Doesn't make any difference. Okay, well that basically does it.
Okay, so we have one more quick test. Both loading rings. See, let me turn this around so I can see it. So both loading rings are gone from here, obviously. And we're going to see which one is going to light this tube the best at the furthest distance, just to compare all the different configurations. And so when we did light before, let's see. I guess on either one it doesn't matter, huh? So let's see.
You got any meter readings?
4, 57.
We kind of have to find. There you
There
go.
we go. That was real sharp. Okay, so this is lit. I'm going to pull it away a little bit as it gets a little bit dim. Go down. You going to turn the light off or?
Yeah. I guess it's seeing the switch. I guess I can find it.
We're at 5661 kilocycle right now. Oh, it's on this side. Yeah, right on this side. This side of the wall, right there.
Oh, okay.
Yep. Okay, so we're at 5661 kilocycle. And I'm basically adjusting the frequency where it's the brightest, and I'm going to draw it a little bit further away. Retune for the brightest, pull it away. Retune for the brightest, a little bit right there, pull it away a little bit. That's the brightest. A little bit further.
Yeah, you're out of range.
So that's about the distance. That's about one tube distance. That's actually, I think, a little bit further.
A little further, yeah.
Wow. That's the furthest. That's
Pretty
12.
good.
That's about 14 inches away. That was at 5679 kilocycle when I'm out here. So for flea power, I can wirelessly light this where the tip of the bulb is about 14 inches away, because it's about 1 foot. So yeah, about 14 inches away. Longer than the length of the tube itself is how far away that was, and still lit it. So that's pretty good.
Okay, well, we run through all the combinations.